Hey everyone, it's Gus from Pi My Life Up. In this video I'll be going through the steps of setting up an analog to digital converter for the Raspberry Pi. The chip I'll be using is called the MCP3008, which I'll touch more on in a bit. As you may or may not know, the Pi doesn't actually have GPIO pins that are analog. This makes connecting analog sensors a little more complex. There are several solutions to the lack of analog pins, like the way I did in the Raspberry Pi photoresistor tutorial, which involved using a capacitor to measure the resistance of the photoresistor. However, using a proper analog to digital converter is a bit more accurate and also allows you to manage up to 8 analog devices. Also go into setting up the chip with My Devices Cayenne. This is a much easier process than writing the code from scratch, but sometimes half the fun is learning how to code. It really just depends what you're after. The circuit for this looks quite involved, but it's all about connecting the wires up correctly. Now there is a lot of technical information on the MCP3008, but I will just touch on the bare basics. This particular chip makes use of the SPI, the Serial Peripheral Interface Bus, which means it will only require 4 pins and is relatively easy to communicate with thanks to the SPI dev library for Python. For anyone who is new to microchips, you'll find that one end of the chip will usually have a notch in it. This represents the end where pin 1 is. Pin 1 is on the left side with the notch facing away from you. Now the CH0 to CH7 pins 1 to 7, are the analog inputs for the MCP3008. These are all located on the left hand side of the chip. On the other side we have a whole range of different pins that I will briefly mention in a bit. If you want more information, then be sure to check out PiMyLifeUp.com. Putting this circuit together is pretty straightforward. It is likely to look a bit messy because we're going to have so many wires, but you can clean this up later if you want to make it more of a permanent project. In this tutorial I have included a photoresistor to show how you can get the value on the Pi using the analog to digital converter, ADC. Before we get started, place the chip in the middle of the breadboard. So to begin, first connect a 3.3 volt pin to the positive rail on the breadboard and a ground pin to the ground rail on the breadboard. So VDD is pin 16 on the chip and is the positive power pin. Wire this to the 3.3 volt rail. VREF is pin 15 and it's the analog reference voltage. Wire this to the 3.3 volt rail. AGND is pin 14 and is the analog ground pin. Wire this to the ground rail. CLK is pin 13 and is known as the clock pin. Wire this to GPIO 11, or also known as pin 23 or SCLK. D out is pin 12 and this is the data out pin. Wire this to GPIO 9, or also known as pin 21 or MISO. D in is pin 11 and this is a data in from the Pi itself. Wire this to GPIO 10, or also known as pin 19 or MOSI. CS is pin 10 and is the chip select pin. Have this go to the GPIO 8, or also known as pin 24 or CE0. DGND is pin 9 and this is the digital ground pin for the chip. Simply wire this to the ground rail. Now that's all done, it's time to connect the LDR up to the chip. First add the LDR to the breadboard. Add a 10k resistor from the LDR to the positive rail. On the other side of the LDR, add a wire that goes to the ground rail. Lastly, add a wire between the 10k resistor and the LDR. That goes to pin 1 on the MCP3008. Now that's all done, it's now time to move on to the code. Now the code for this is pretty simple, but keep in mind it is only handling just one input, and that's the LDR. The code may get a little more complex as you add different devices. All the required packages for this tutorial should be installed by default on Raspbian. Now by default, SPI should be enabled for the GPIO pins. You can check this setting in the Raspberry config, or also known as the Raspberry Pi configuration within the GUI. It's located under the interface tab. If you do come across any issues, then be sure to check out my guide on Raspberry Pi GPIO pins. It goes through how to set them up and install the necessary software. Now, to quickly download the code straight onto your Pi, simply run the following line: git clone https://github.com/pi-adc-example-code. Once downloaded, you can launch it by running the following: cd./pi-adc-example-code sudo python adc-code.py. As you can see, it is reading from the sensor fine. If I hold my hand over it, you can see the change in the value, and if I remove my hand, it goes back to the value it was. You can now cancel the script by pressing Ctrl+C. I will now just quickly go through the code. At the start of the code, we define the path of where Python is installed. After this, we import two packages that we'll need. Time allows us to put the script to sleep, aka a delay. SPI dev allows us to communicate with SPI devices. In this case, it is the MCP3008. Next, we define the variables and create our SPI dev object. We create two variables, first being a delay. This is in seconds. Alter this if you want there to be a greater amount of time between updates. And next is the channel our LDR is located on. In this instance, it is channel 0. Finally, we create the SPI dev object. This allows us to get the values we need from a chip connected to the SPI enabled pins. Next, we have our read ADC function, in which we do a couple of things. Firstly, we check the parameter value to make sure it's between 0 and 7. If not, return -1. If it is, we proceed to get in the value from the channel specified and then return the value. Lastly, we have a while loop. This continues until you force quit it by pressing Ctrl+C. The first thing we do is call the read ADC function with the LDR channel variable as the parameter. Once we get the value back, we simply print it. The %d refers to a decimal value. We then have our variable after the double quote content. You can print multiple values per line by doing something like this: print %s %d name, comma, number, bracket, where name and number are variables. After we have printed the data, we delay the script for whatever the delay time is set at. By default, it is half a second. I hope that explains the code. As I mentioned before, you can download the code over at GitHub or over at PiMyLifeUp.com. I will now quickly go through the steps of setting up the MCP3008 with Cayenne. I will also go through the steps of how to set up the LDR so that it can read the correct input. If you haven't already seen it, then be sure to check out my guide on how to install Raspberry Pi Cayenne. It goes through the steps to getting it installed and most of the basics you need to know. So in the Cayenne dashboard, go up to Add New and select Device from the drop down box. Then either search or select Analog Converter. In this list, select MCP3008. Now select your Raspberry Pi and SPI chip select 0. And this will now bring up the screen that shows you all the values of the channels. As you can see, I just have one for now, but if I add more analog devices, I can see all the values right here. Now to add the LDR, the process is pretty much the same, but I'll go through it anyway. Go back up to Add New, and then select Device. Find or select the photoresistor. For this one, select your Raspberry Pi, your preferred widget, I went graph. Then select the MCP3008 for the analog converter. And finally, channel 0 for the channel. This should now add without any issues. It will now produce a graph from the values it gets from our analog converter. Now you can pretty much follow the same process for any analog device. I will be covering more sensors and devices that are analog in the very near future. This includes things such as the TMP36 temperature sensor. Now I hope this tutorial has helped you with setting up an analog to digital converter for the Raspberry Pi. If you do come across any issues, have feedback or notice a mistake, then please feel free to leave a comment below or over at PiMyLifeUp.com. Until next time, have a good one. Looking for more Pi projects to do? Check out these 21 awesome Pi projects that anyone can do. Don't forget to subscribe so you can stay up to date with the latest and greatest projects, guides and much more.